Welcome to video 15, which is a tutorial on Pythagoras and trigonometry. This work is aimed at students studying the higher AQA Unit 3 GCSE, and in particular for help for students who've previously set the foundation who are trying the higher. In this video I'm going to show you all the trigonometry you need to do with right-angled triangles. So everything in here is going to do with right-angled triangles. But before we do that, I just want to give you an overview of triangle trigonometry. Now, there are lots involved in Unit 3 with triangle trigonometry, but it depends, okay? There are two cases. The first case are for right-angled triangles, if we have right-angled triangles, okay? Right-angled triangles. There are two things that usually apply in this case. The first thing is Pythagoras' theorem, Pythagoras, and the second thing that applies is SOHCAHTOA, which is trigonometry. Okay, and we'll get onto that during this session. Okay, next is for non-right-angled triangles. Now this video won't cover this, but my next set of videos will. But just to, you should always be thinking what is applying here. So non-right-angled triangles, and various rules apply here, but mainly the main rules are the sine rule and the cosine rule. So they're the main four things that are in play. If you've got right-angled triangles, you should be thinking Pythagoras, SOHCAHTOA. If you've got non-right-angled triangles, you should be thinking sine rule or cosine rule. Okay, this video is all going to be about right-angled triangles, so I'm going to remind you of Pythagoras, which is a foundation topic, you should know that, and move on to trigonometry or SOHCAHTOA. That's a topic you wouldn't have seen before. So let's take a look straight away at Pythagoras. Now, I would expect you to know Pythagoras from foundation level. Pythagoras' theorem says that it says that we call the longest side of a right-angled triangle the hypotenuse. Okay, we always call it what's called the hypotenuse, okay? And if we label that, say, C, okay, that's always the longest side of a triangle. The longest side is always opposite the right angle. Now, the other two sides are what we call the shorter sides. We can call them A and B in any order, it doesn't really matter. Pythagoras said that if you square the hypotenuse, you get the squares of the other two sides added together. Okay, so you might see that written in the formula booklet, or you might see that written in textbooks. So a squared plus b squared is c squared, okay, i.e. the hypotenuse squared is the sum of the other two sides squared. So just to give you an example, let's just rub that out there. If I didn't know this side, the longer side, it's opposite the right angle c, but I knew this one was 3 and this one was 4, c squared I know is 3 squared plus 4 squared. Okay, you work that out. 3 squared is 9, 4 squared is 16, so that's 9 plus 16. You add them together, you get 25. Now that's c squared, it's not c, so to get c I square root it, square root of 25, which is 5, and let's say the unit was centimetres, so it'd be 5 centimetres. Okay, now alternatively, say I got, say if I knew this side here was say 10 centimetres and I knew this side was 6 centimetres, what's this side here, which I might call say A or something like that? Well, using Pythagoras' theorem, I know that the longer side squared is equal to the two shorter sides squared added up, so A squared plus 6 squared. So therefore 100 is equal to a squared plus 36. Okay, subtract 36 off both sides, I will get 64 is equal to a squared, subtracting that 36 from both sides, and then square rooting, because I've got a squared, a would therefore be the square root of 64, which is 8. Okay, now some students might, in particular if you're doing the foundation, might find the algebra and the rearranging difficult here. Now I prefer students to use this method because it helps you with other type of work, but if you are very much struggling with this here, I'll leave in the questions and I'll show you a different way of doing it. It requires more memory, but you might find it slightly easier to process if you're solving an equation solving or rearranging equations isn't that good. Here you're trying to find the longer side. Let's call that x, say. If you're trying to find the longer side, you square the numbers, okay? You add them, okay? And you would do 4 squared 16 plus 9, and you get 25, and then you square root them. So square root of 25 is equal to 5 centimeters. Okay, you might find that easier. If you're working out one, the longer side is that one. So if you're working out this side, it's one of the shorter sides. So you square them, and always do the big one first. Square it. Instead, because you're working shorter side, you subtract. So you do 10 squared minus 6 squared. You get 100. Take away 36 is 64, and then you square root. Square root of 64 is equal to 8 centimeters. Okay. And that's how you do those. Now, I'd like you to have a go at these two below. Just pause the video for a second. Have a go at working those out. The algebra method I first showed I prefer, but if you're struggling, rearranging like this, this sort of add, square them, add them or subtract them, square root, if that works for you, then so be it. So have a go for a minute, and then I'm going to show you the answers. Okay, I'll show you, we're working out the longer side here. So you take the numbers, you square them, longer side, so you add them, and you would get 136, and you would take the square root of that, and you would get 11.66 to 2 dB, 11.66, don't forget your units, centimeters. And if you're working out the shorter side, because that's the longer side, this is one of the shorter sides, you square the numbers, bigger one first, shorter side means subtract, so you get 400, take away 36, it's 364, and you'd square root 364, and you would get 19.08 centimeters. And just double check, do they look sensible? Yeah, that's bigger than these two, it's sensible. And this is shorter than that one, yeah, that could be about right. Okay, Pythagoras was a foundation level topic. You should be familiar with that. That should be easy for you. Let's move on to something that is a higher paper topic. Now, Pythagoras only worked for right angle triangles. And let's just recap. What you needed, Pythagoras was to find a side, okay, when you have two of the sides, when you know are the two sides, and for a right angle, okay? So Pythagoras was only of any good to you if you were trying to find the length of a side and you knew the other two and you had a right angle triangle. Okay, now this may in itself be a revision card for you, so I might suggest you maybe pause the video and make a copy of this. I'm going to explain to you what it means by way of examples, really. But just to start us off, trigonometry or trigonometric ratios are used to find sides, to find a side, okay, if you know two things. You know one side and one of the acute angles, not the nut and one acute angle, okay, or it can be used to find an angle. You can find an angle if you know two sides. Okay, so remember Pythagoras, finding a side if you know two sides. Now trigonometry helps you find a side if you know one of the sides and one of the acute angles, or it helps you find an angle if you know two sides. Okay, now important thing with trigonometry is you have to be able to label your triangle correctly. Now the hypotenuse is always, we call it h, and it's always opposite the right angle, just like Pythagoras. Now everything else is in reference to the angle you are trying to find or you are given, the acute angle. So say here, we're either asked to find this or we are given it as a number. Everything you label corresponding to that. This side is opposite the angle, so it's called the opposite, or O, and this side is beside the angle, is adjacent to the angle, so we call it A. Now, SOHCAHTOA is a way of remembering the trigonometric ratios. I don't really usually write them like this. I write them like with the O above, the A above, and the O above here. SOHCAHTOA. It helps us remember the following relationships. Sine of the angle is equal to the opposite side divided by the hypotenuse. Cos of the angle is the adjacent side divided by the hypotenuse, and tan of the angle is the opposite divided by adjacent. These triangles just say that, or just like this here. Now, I'm going to show you exactly what they mean in questions, okay? But just do bear in mind, you have to learn this, SOHCAHTOA. So means sine of the angle is opposite over hypotenuse. Ka means cos of the angle is adjacent over the hypotenuse. And toa means tan of the angle is opposite over the adjacent. You've just got to learn that and commit that to memory. It may help you as we're going through the examples what everything means. Do just look there carefully. It's the angle that you apply sine, cos or tan to, those buttons on your calculator, okay? Not a side, sine of an angle. Okay, let's just do examples. I'm going to do an example, then I'm going to give you a chance to copy a very similar example, and then I'm going to put the answers up. So this is how we're going to do it. First example here. We have got an unknown. We have got one side given to us and one angle, and we are asked for that side. Okay, step one with these questions. Okay, always label your triangle. Here's the angle we are given in this case. Let's label the sides we want to know and are given. Okay, so forget about this. We don't need that, and nothing's talking about that. We need to know this one, and we've got this one. Now, the x is opposite the 33, so we're going to call it O. And the 25 is opposite the right angle, so we're going to call it H. Okay, so we ask ourselves, which of So, Ka, and Toa has O and H in it? Well, So does. Okay, and we're going to write down that in our triangle. We're going to use So. Okay. Always write down the equation you're going to use. So stands for sine of the angle. Okay, just call it theta for now, even though we know it. But just sine of the angle is opposite divided by hypotenuse. Write down the meaning of so. Now substitute in sine, and what's our angle? 33 degrees. Sine of 33 degrees is equal to the opposite, which is x. We'll want to find that out, divided by h, which is 25. Okay, now we want to rearrange this equation. Times both sides by 25. The 25 will end up over here. So I would get 25 sin or sine 33 is equal to x. Okay, so then working that on the calculator, work out 25 times sine 33 equals, and I would get x is therefore equal to 13.62. 13.62 centimeters. Okay, so step one, label your triangle with reference to your angle. Step two, pick your correct SOH, CAT or TOA and write down what formula you're going to use. Step three, set up your equation by substituting in. And step four, solve your equation and round appropriately. Okay, very similar question for you to try now. I would like you to pause the video, have a go, and then I'm just going to show you the answer. Okay, you've had enough time there. Here is the answer. And the answer was 14.32 centimeters. You had to use SO, which was sine theta is O over H. Substituting in and solving, we got 14.32. Okay, take a look at my next example. Again here, we have been given one side and one angle, and we're asked to find the other side. Okay, so we can't use Pythagoras because that was to find a side if you knew two sides. It's a right angled triangle, so SOHCAHTOA or trigonometry has to be in play. Step one, label your triangle. Here's my angle. This side must be opposite, and this side is opposite the hypotenuse, the right angle, so it must be the hypotenuse. Which of SO, CAT or TOA has O and H? Well, SO. So we write down that. Now what does SO mean? It means sine of the angle is equal to opposite divided by hypotenuse. Okay, good. Let's substitute now. Sine of, well, what's the angle? 41 is equal to opposite, which is 12, divided by hypotenuse, which is x. That's the thing we're trying to find. Okay, now rearranging that equation, I'm not going to go into the detail of this here, but rearranging that equation to find x, really what eventually happens is that this and this swap places. Okay, they've swapped over. The x has gone up here and the sin 41's gone down here. Okay, so I'm not going to go into that in that video. Either you understand that or just remember that for now. Okay, so then you type in your calculator 12 divided by sin or sine 41 and you would get 18.29. So you get equals 18.29 centimeters. Okay, the difference with this question is this step here where we have to bring the x on top and bring the sine 49 on the denominator. Okay, have a go at a question very like this, pause the video and then check the answer. And the answer to this question, let's just take a look here. The answer to this question that I got was 102.37 meters here as well. I did swap it in just to check you were doing it right. Always don't forget your unit, okay? So we're using SO, okay, and then rearranging, we got 102.37 meters. Okay, next question. I'm going to show you an example. You follow, then have a go at one yourself. Okay. Right angle triangles, so you're thinking Pythagoras or trigonometry. You don't know two sides, so it can't be Pythagoras, it's got to be trigonometry, and you're given an angle. Here's your angle. Label up your triangle. The side opposite the right angle is the hypotenuse. Okay, so label it H. And here, the side beside the angle, we call it the adjacent. So what of SO, CAT or TOA has A and H? Well, CAT does. Let's write out what that means. It means cos of the angle is the adjacent divided by the hypotenuse. Okay? Now let's substitute in and try and solve. Cos of 53, which is the angle, is x divided by 18. Okay? Now rearranging to get x, the subject, times both sides by 18. The 18 ends up here. 18 cos 53 is x. And you just type that in your calculator. So you type 18 times cos 53, making sure your calculator is in degrees mode, you get 10.83 and centimeters. Okay, and you're done. Right, have a go at the next question, pause the video, and then check your workings with my answer. And the answer to this one was I got 13.26 meters. Okay, 13.26 meters. Okay, let's have a go at another question. Always start, label your triangle. So this is my angle here. The x is opposite the right angle, so it must be the hypotenuse, and the 7 is the adjacent. What of SO, CAT or TOA has A and H? Well, CAT does. Write down what CAT means. It means cos of the angle is the adjacent divided by the hypotenuse. Substitute in. So cos of 47 must equal 7 divided by x. X is your hypotenuse. Remember this, we want to get x, the subject, so this here swaps with this, and we would get x is equal to 7 over or divided by cos 47. Type that in your calculator, and you'll get 10.26. So 10.26 centimeters for x. Have a go at the next question, pause the video, check your answers with my answers. And the answer to this one, we were using CAT, and I got 11.95. Okay. Right, another example. Obviously, you get the message here. We've done SOHCAHTOA. We're going to move on to TOA, or the tan one. So, step one. Here's your angle. Label your triangle. This is opposite. This is beside the angle, so it's the adjacent. What if SOHCAHTOA or TOA has O and A? Well, TOA, write it down. Okay, say what TOA means. It means tan of the angle is opposite over adjacent. So in this particular case, tan of 23 is equal to the opposite, which is x divided by 6. Times in 6 by both sides, we get x is 6 tan 23. And therefore, typing that in the calculator, you get 2.55. So I've got 2.55 centimetres. Okay, have a go at the next question, pause the video and check your answers with mine. And the answer I got is as follows, 8.29. Okay, another one. Here's your angle, this is your opposite, this is your adjacent. What has O and A? Well, TOA does, so write it down. Write what TOA means. It means tan of the angle is opposite over adjacent. So in this case, tan of 37 is 11 over x. And making x a subject, the x and the tan 37 swap, I get 11 over tan 37. Type that in your calculator. I get 14.60. X is 14.60 centimetres. Take a look at the next question, pause the video, have a go, check your answer with mine. And I got 18.85 centimetres. Now, quite deliberately, I've shown you every possible scenario. You can use sine, cos and tan to find the opposite, hypotenuse or adjacent. Okay, so I've shown you all the possible scenarios and let you have a go. The other thing trigonometry can do is find an angle that you don't know, but as long as you are told two of the sides. So let's do 3 examples of that and then I'll let you have a go at a few questions. Here, we're finding angles, okay? It's the exact same thing, but there's one step at the end that's a bit different. We are asked to find this angle here, okay? And we are given 2 of the sides. So, the thought process here is, I've got a right angle triangle, I'm finding an angle, it's got to be trigonometry SOHCAHTOA. Right, start off again by labelling your triangle. The 10 is opposite, and the 20 is opposite the right angle, so it must be the hypotenuse. What if SOHCAHTOA or TOA has O and H? Well, so write down what that means. Sine of the angle must equal 10 divided by 20, okay? So sine of the angle is 10 over 20. So to get the angle out of that, I apply what's called the inverse sine to 10 over 20. Okay, so the inverse sine gets me the angle out of the sine theta, and I inverse sine 10 over 20. On my calculator, it's usually shift sine 10 divided by 20 close brackets equals. Okay, that will get me the answer. So if I do that, I would on my calculator press shift sine, that gets the inverse sine, 10 divided by 20 close brackets equals. And with a bit of luck, you got theta is 30 degrees here. We found an angle, so it's degrees. Okay, let's try another one. Again, find an angle. Here's the angle I want to find. Label it with reference to the angle. This is the opposite, and this is the adjacent. What has O and A, or TOA? Okay. So, write down what that means. That means tan of the angle is opposite, which is 36, divided by 12, the adjacent. So I should have written down, I've skipped a step. Tan of the angle is opposite over adjacent. Okay, so to get the angle, I inverse tan this. So the way I usually type that in my calculator is shift tan 36 divided by 12 close bracket equals. And I got there, theta was 71.57 degrees. Okay? And last one, here's my angle. This is the adjacent. This is opposite the right angle, so it's the hypotenuse. What has A and H? Well, K. What does K mean? It means cos of the angle is A over H. In this case, cos of the angle is 5 over 50. So that's cos of the angle is 5 over 50. To get the angle, you inverse cos 5 over 50. So you shift cos 5 divided by 50 close brackets equals, and you get 84.26 degrees. Okay, and that's everything about right angle triangles. Okay, if you're given two sides and you want to work out the other, it's Pythagoras' theorem. If you're given any other combinations, so you're trying to find a side and you've given an angle, you use SOHCAHTOA. Or if you're given two sides, if you're given a side and an angle, you use SOHCAHTOA. Or if you're given two sides and you're trying to work out an angle, you also use SOHCAHTOA. There are four questions here to have a go at the end. 6 questions to have a go at. Just pause the video for a second, find angles A, B, C, D, E and F, just like we've been doing, and I'll put the answers up in 5 seconds. And here are the answers. I haven't shown all the workings, I've just shown I've used SOHCAHTOA, CAHTOA and SOH there, and I got the answers in here. So that's everything you need to know on right angle trigonometry. Move straight on now to the video on the questions that come up on this, so you can practice your Unit 3 exam style questions on right angle trigonometry and Pythagoras. Thank you for watching and see you in the next video.